Hi everyone, so today we're going to talk about chapter 8, the transfer of thermal energy. Thermal energy is transferred from a place of higher temperature to a region of lower temperature. So as you can see over here, this is a house iron and this part of the plate would be hot. So your hand over here would be cooler, therefore heat would pass from the hot iron to your cooler hand. There are three processes by which heat can be transmitted: conduction, convection, and radiation. Definition of conduction is a process by which heat is transmitted through a medium from one particle to another without any flowing of the material medium. None of the medium can move from one place to another. Different materials will conduct heat at different rates. For example, metals conduct heat much faster than non-metals, and that's why you use metals in your cooking pots and pans. This is the first type of conduction, and this is called the normal type of conduction. This type of conduction occurs for all matter, no matter whether they are metals or non-metals. This is due to the vibration of particles. Remember from the last chapter, we said that solids had particles that were vibrating. Well, this vibration is now being used to pass heat. So now over here we have an example. There's a rod over here, and imagine one end is put near to a candle. The candle is lit and it provides heat. So this heat will obviously start to make this end hot. The particle gets hotter, it will vibrate faster. So over here, when the heat goes into these particles over here would vibrate from a slow vibration. They'll start to get faster and faster vibrations. And then what happens is that there will be particles that are next to them, what we call neighboring particles. So imagine if one particle over here is vibrating vigorously and one particle is vibrating less vigorously. This particle over here that is vibrating vigorously would collide with the neighboring particle. And this collision with the neighboring particle makes the particle also start to vibrate vigorously. This neighboring particle once again starts to collide more vigorously with the particle that is next in line. And there you have it. The chain of vibrating particles will start to spread. And finally, when the particles over here that are vibrating the least vigorously at the cold end, and the increase in vibrations occurs all the way to this point, that is how heat has passed through the metal rod through conduction. In summary, when the heat is supplied at one end, the particles at the hot end gain energy, vibrate vigorously, and they collide with the neighboring particles. Some kinetic energy of the vibrating particles at the hot end gets transferred, and in this way it passes on and on to each neighboring particle until it reaches the cold end. And this is true vibration. Now we have the second kind of conduction, which is for metals only. Now metals have this special thing inside them that is free flowing, and this is called electrons. If you have ever seen a piece of wood that is infested with an ant's nest, you would sort of get what I mean. Imagine the piece of wood and it's swarming with these ants. That is how you could imagine electrons to be swarming through metal. Anyway, because of these free electrons, metals can transmit heat quite fast. So imagine this is a metal rod instead of the previous rod that was not metal. Firstly, this metal rod also undergoes the previous form of conduction, where these vibrating particles would start vibrating more vigorously and vibrate the neighboring particles and pass along the increased speed of vibrations to the cold end. However, besides this form of conduction, it also has the electron movement transfer, whereby the particles over here that vibrate more vigorously can excite the free moving electrons over here. And when this free moving electron gets excited, so this free moving electron can travel through the metal and it will move towards the colder end. When it has moved a short distance, it can collide with a particle that is further along the metal rod, thereby passing the energy to this particle. Therefore, you can see that with the free electrons, you can actually skip particles instead of having to go through every single neighboring particle like the first one. So in summary, for metals only, there is a presence of a large number of freely moving electrons. When heated, these free electrons gain energy and they move faster. Electrons are free to travel in the spaces between the particles, so they can actually move a short distance before colliding with another particle and transferring some energy to them. They will always move towards the colder end, and therefore you can actually skip particles. The rate of thermal energy transfer in metals is faster than that in non-metals. These are some examples of good conductors and poor conductors. Gold, silver, copper, iron, brass, aluminium. Very clearly, metals are good conductors. Poor conductors are almost everything else: glass, stone, water, plastic, wood. Also, materials that contain trapped air are also bad conductors, like polystyrene foam, wool, and fiberglass. Air itself is quite a bad conductor, mainly because its particles are quite spaced out and therefore have a hard time colliding with each neighboring particle. Uses of good conductors. Good conductors are used in situations where heat has to be transmitted quickly. So over here, marble and ceramic floor tiles help to keep feet cool in hot countries like Singapore. Saucepans and pots would use metal because they are good conductors and they need to conduct the heat fast to the food to cook it. However, the handles that you use to hold these pots, you should use materials that are not good conductors, that should be insulators, because when you're holding the handle, you don't want the heat to pass to your hand so fast because you would be burned by the heat. Also in this case, the polar bear has nice thick fur. This is because the fur traps air in between the spaces, and air is a poor conductor of heat. So the polar bear can live in very cold conditions because it can maintain its body heat well. In summary, thermal energy can be transferred by conduction, and conduction requires a material medium in order to take place. Metals will conduct heat much faster than non-metals because the non-metals have no electrons. And we also talked about the uses of good and poor conductors.